So we are going to start functions. Let me share my screen. Okay, so before we start functions, so is there any questions from yesterday's class on the branching statements, loops, switch statements? Any questions from anyone on that? Okay,
No,
all right.
we are good to go. Yeah.
Okay, yeah, thanks. Okay, so now, so we are today we are going to discuss functions concept. Okay, so functions is nothing but a set of statements which are designated to perform a specific task. So it could be a smaller task, or it doesn't matter whether it contains two statements or four statements or like 100 statements, but it is a set of instructions to achieve one specific thing. And when I say specific thing, we can do that end to end in that particular function. So how it happens is in functions, uh, we pass some of the parameters as an input. Okay, and also we could expect a parameter as an output also. So it takes some values and also it returns some values back to the main function. Okay, so the advantage of function is if you keep the function separately, you can invoke that function any number of times in your program. That means like writing the code one time and use it any number of times. Okay, and functions is in general, like there are a lot many synonyms for functions. We can call it as modules, methods, or procedures. Okay, so if you remember, like in the very first class I mentioned, what is a class? Class contains variables and methods. So methods means it could be a function, or I could say procedure, or I could say modules. So all are same basically. So why this functions concept came, right? So if you write everything in a one program, right? Let's say like I think this also I have mentioned in the very first class. So if you write everything in one main program, okay, so there is a lot of problems, because you're trying to write everything end to end in one program. So the problems with this monolithic kind of programming is that, like the main problem what I could see is that, like see, in today's world, okay, there are a lot of people working simultaneously to achieve or to write a bigger project, right? So if you say that, like if you give this monolithic concept or monolithic programming, you, nobody can write, any number of people cannot write the program. Only one person has to take it, because it's only one program where we are writing everything end to end. So the monolithic programming, there is no way you can have more than one programmer working to develop the project. And also, suppose if there is a problem in the program, okay, so if you want to debug, okay, it would be a challenging, because you have to go through from the line number 1 to line number 1000. So it would really cumbersome to debug and identify the issue. And one more bigger problem what I could say is, like if we have a big program in one method, right? So what happens is, as you know, whenever we declare any variables during the execution time, those variables are stored in the primary memory. So if you keep everything in the main program, so all those variables will be available on the main memory until the program completes. Why? Because I am writing everything in one program. So everything has to be loaded into the main memory, and until the method is completed, those variables will continue to reside on the primary memory. Okay, so these are all the typical, like, the drawbacks of the monolithic programming, and that is the reason we have the concept of modular programming and also object oriented programming. So here, how it works is, so now you know that, like, as of now we are writing everything in the main method, right? We have main method. Okay, and now instead of writing everything in uh, one main method, right? You can divide the program into smaller chunks. Okay, and you can write into different functions. So you can say, like, function 1 to achieve some task, function 2 to achieve some another task, function 3 to achieve one more task. So in the main program, main method, I have three functions here, and these three functions I'm only here. See, if you see this one, right, this is basically I am invoking this function 1, then function 2, then function 3. But so when I invoke this function 1, right, the control transfers from here to here, the function 1, and it executes whatever the statements I have mentioned in the function 1. And again, once this function 1 statements are executed, the control comes back to the function 2. Okay, again I'm invoking function 2, again the control goes to the function 2 here. It will execute the statements which are there in function 2. And when this is done, it will again come back to the main method. Now it executes function 3. Again it calls to function 3 statements. Then again it will come back. Okay, after function 3 there are nothing more, so it will simply come out of the program. So if you see, like, you have separately, you have logically divided your code into three different functions, and you're working three different separately one by one. So as I said, like, if you want to use this function 1 n number of times, you just need to call this. You say, okay, just execute function 1. Okay, so that is called, modular programming. You're dividing into the modules. Okay, and the same thing works for oops also. So now if you see that, like, that functions are a set of instructions, okay, written to solve one specific task. Okay, and these functions are two types in C#. One is built-in functions, one is user-defined functions. As the name depicts, right, built-in functions means the functions which are already provided by the framework or by the programming language. Okay, so right, the base class libraries. So it contains those functions. It is already available for us. Okay, you just need to invoke it. So built-in functions, you can simply invoke it. So here built-in functions, right here, if you know the function name, you just invoke this function name. Okay, you don't need to write the code for built-in functions because it's already there in the BCL. Whereas if you wanted to achieve, or if you have some customized uh, solution you wanted to implement, and that method is not available as a base class library, so you have to write your own method, your own function, that is called user defined functions. So it says user, right? User defined. Users means we. So we are writing our own functions for our program needs. So that's why it is called user defined functions. So built-in functions is, it says built-in, already built by the .NET framework or by the C# program. Okay, so built-in functions are also, you can mention as predefined, already defined by the base class library. So it's a predefined functions. So predefined and built-in both are same. User defined is something which programmer is trying to write to achieve his specific task. So clear, any questions at this moment? I can explain you, how to invoke the built-in functions. You guys are already familiar with these built-in functions, but I just wanted to show you, like, how it works. Okay, so here if you see, there are some built-in functions I'm trying to use. It's mostly the math specific. Okay, so if you see, I have declared one number 25, and I wanted to know what is the square root value of 25. Okay, so there is a method or function or module called square root, okay, which is part of math class. So math is a class, square root is a method. It is already built in, provided by the .NET framework. So to in order to get the square root value, you just need to pass the value here. So you pass this 25 to this square root method, and the square root value is going to store in the square root variable. Okay, so then I'm just printing what is the square root value of this 25. Okay, and I'm taking a few more examples. One is power. It's like 4 to the power of 2. Again, it's a math class. Power is a method within the math class. Okay, so I'm just asking, like, what is the value of 4 to the power of 2. Okay, and one more is, I am trying to get the floor value. So floor value, I mean, do you know, guys, floor and seal? Did you come across any time floor function and ceiling function? Suppose if it is if you have a real number called, like, 10.5.
Yeah, I know a little about seal keyword. Hello.
Hey, sorry guys, my laptop, like, no charging gone, so I have to plug in. Okay, can you hear me?
Yes, I know.
Okay, so let me share. Hey Siva, can you enable the sharing option? It says host disabled.
Lalichand, you are the host. Can you please give access to give host to Venona? Lalichand,
Hey Lalichand,
I will call him, Anna.
yeah, I think he made me host now. I'm good.
Yeah,
Let me share.
perfect. Okay.
Okay, you can see my screen, right?
Yes.
Yes,
Yeah.
Anna.
My son changes the profile name every day, man. Think now you could see a name Sidhu, right?
Yeah.
You know, okay. I think my son changed it. Okay, never mind. So I was showing the example, right? Okay, so we are talking about the built-in functions. So I was talking about this ceiling and flooring, right? Suppose if you have a decimal value right now, 10.5 or 10.6 something. Okay, I'm just taking one decimal value. So if I say floor, right? If I say floor, it will, you know, remove this. It will just forget about the decimal portion and it will consider only the whole number part. So it just drops this decimal portions and gives the floor value. Floor value. When I say ceiling, okay, it goes to the next whole number, which is 11, and prints 11. Simple. It's the floor is the lower whole number. Ceiling is the higher, the next whole number. It's a kind of a, rounding the value, but floor always, because rounding is all depends upon if it is the decimal value is greater than 0.5 or not. But here the floor is always drops the decimal portion. Ceiling is always goes to the next whole number. Okay, and there is one more method I'm using, max. So you give a couple of variables, a couple of values to the function. It and also a minimum value. So let me try to execute this. Okay, so square root of 25 is 5. 4 to the power of 2 is 16. Floor, what is 3 by 2 is 5. What is this? Okay, sorry, it's 101, right? 101 by 2 is actually 50.5 something, right? But it is given the floor value as 50. Okay, you see ceiling value is always the next whole number, which is 51. Okay, so maximum number between 5 and 10 is 10. Minimum number is 5. So guys, like, you are already familiar of using the built-in functions. Okay, though I'm trying to explain here, the math square root function or power function. Okay, but you're already using. Okay, and the classic examples what I could given is the right line. Is it a method or not?
Yes, Anna.
Yes. And the read key,
Yes, Anna.
right? So any method, after the method name, you'll have this brackets. You'll have this brackets, and you can pass the values to the method. Okay, so here you see, right, the for write-ln, this is also method. You are passing some value here, right? You're passing some value. So and so already, as you know, a class contains variables and methods, and we already started using methods implicitly from the beginning of very first program, because write line, read key, all are predefined functions methods already available by the BCL. And by importing the namespaces at the top here, we are directly using the methods which are available in the class. Okay, so and as I said, a class contains variables and methods, right? So now you see, right? So this is a main class. Sorry, this is the program class. Okay, and you are having the variables, you are having methods, right? So basically, now you know that like now class contains the variables and methods. Okay, and now you see you have the variables and you have the methods. Okay, any questions in the built-in functions? I just taken few examples to show that like how a built-in function works, but in reality we need to focus more on the user-defined functions.
Yeah,
Okay,
we are good to go.
good to go. Okay, thank you. Okay, so user-defined functions, as the name depicts, as I mentioned, it is defined by the programmers to solve one specific purpose. Okay, so instead of writing everything in one main method, you can divide into smaller chunks. Okay, and you logically group them into the functions. So advantage of using the functions is that like now suppose your main program is divided into 5 or 10 modules. So you can, if you are multiple programmers going to work on, right, so you can easily give, okay, hey, you work on this module 1, I will work on module 2, okay, you guys work on module 3, like that. So it's easy to distribute the logic or the program to multiple developers. Okay, and once everybody written their own module, then you can integrate everything into the main module and you can easily execute the program. And if you know that the problem, suppose like if there is one problem, right, so when you debug the program, right, okay, so now once you started debugging, you will be easily identify where the program is issue, and the particular programmer who developed, right, he can easily go through his own set of code and quickly come up with the issue and resolution as well. So it's very easy to understand, very easy to maintain, or very easy to debug. Okay, and see, one more advantage of user defined functions is, okay, so as I said, if it is everything in the main program, all the variables are going to be available on the main memory. But if it is any variables you are defining within the function, right, so when the program starts, the whatever the variables you are declaring in the functions, it won't be overloaded, it won't be uploaded into the main memory. Once the control comes to the function execution, that time only the variables within the function will be loaded into memory. And once the function is completed execution, then it removes those values from the memory. That means whenever you use the method, that time only the variables are going to be available. And once you come out of the function, it is going to be erased from the memory. Okay, so if you want to write any user defined function, right, so these are all the things you have to remember how to write. It's kind of a syntax. Okay, so if you want to write that the method syntax, right, so there are 6 different parameters or the keywords you have to remember. The first one is the function name. Okay, so obviously you need the function name. Okay, if you want to add 2 numbers, you can say like add 2 numbers. If you want to print students marks, okay, print student marks, some kind of name you have to write. Okay, so the function name, you have to write the function name. And the second thing you have to remember is the parameters list. That means, as I said, function, using the functions concept, we can pass some of the variables as an input, that is called parameters list. Okay, you see parameters list. So you can pause if you want, you can pause the parameters to the function. So I said function can take 0 or more parameters. That means parameters are optional. That is the reason if you see read key method, are we giving any parameters? Because it's not required. So I just give only, open and close the brackets. Okay, so now the parameters we are giving as an input, and there is one thing called return type. So remember, function can return a value. Okay, so if you need to send back any value from the function, okay, so this is the place. So you have to declare that in the return type. So remember, you can only pass one variable from the function to the main method. Okay, and another thing is access modifier. Okay, access modifier is nothing but like, we for every method, we mention, right, public or private or protected. So these things, like, I will explain more when we start the OOPS programming in the next week. But you just say that, like, public, private, protected. So public means it can be accessed from outside. Private means it cannot be accessed from the outside of the class. Protected means, okay, you cannot change that method in the child class. So it's access modifier. And one more access specifier, sorry. Another one is modifier. So this is a optional parameter. Okay, so normally, like, we can pass the static value, virtual, partial, or sealed. Okay, so if it is static, right, if it is static, you can access the method directly without creating the instance. So normally, guys, like, if you have a class, if you want to use that the methods within the class, normally we create the instance, we will create the object, right? But in this case, if it is mentioned as a static, you don't need to create the instance. And if it is a sealed modifier, I mean, for now you can ignore, I'm just, since the concept came, I'm telling. Okay, but I can cover more about this in the next week class. Okay, and function body. Okay, so just show you with an example, that way, like, it would be easy for you. So remember function name. Okay, it has some set of parameters, it has a return value, and it has a access specifier, modifier, then function body. Let's take this. This is the function I am writing. So here, this is the access specifier, public. Okay, you see here, right, the access specifier here. It could be private or protected or public. So I just mentioned public. That means this function can be accessed outside the class also by declaring or by defining the instance of this class. Okay, so access modifier I mentioned. Okay, so what is the second parameter here? So access specifier I mentioned, modifier. So this is optional. You see, these two are optional here. So the thing which is mandatory is, guys, the method name, which is max. Okay, and max is the method name, and it is taking two parameters as an input. One is integer x, another one is integer y. So max is a function which is taking two parameters as an input. Okay, and before the function name, there is one thing I mentioned as int. Int means this method is going to return an integer type value. That means from the function body, you are going to pass the integer value back to the main method. So you're clear, right? The function name, the input parameters, and the output or return parameter. And this is function body. Okay, so only this access specifier and modifier. Okay, these are the two things which you are not fully clear. Okay, and there is a reason why I'm not going in detail about this. Okay, but just remember that these two are optional. Okay, and for a namesake, I'm just mentioned as a public, as a, okay, and then this modifier, I'm not going to keep anything for now. Okay, static or virtual or partial, I'm not going to keep. Okay, so just remember this syntax. I am declaring a public method. The method name is max. It is taking two parameters of integer type, and it is returning one value of integer type. So any questions on the syntax of a function? Just I will just wait for a minute, just see how the syntax is for the function. The function name, the parameters, return value, function body, access specifier, which is public, and modifier. I have not included modifier because it is optional. Take a closer look and ask me if you have any questions. Here I am using in the function body. You see that I am sorry. Okay. If you are not speaking, can you go on mute, please? Krishna Reddy, can you go on mute, please? Okay. So guys, here if you see, I mentioned that this max method is capable of returning one value, which is integer type. Okay. So how I can pass that value? By using this return statement. So I'm saying that, okay, hey, return the value of X or return the value of Y to the caller. Okay. So so remember guys, there are two things. Okay. Let me open and show you. Okay. So few things I wanted to explain. Okay. So the first thing is, just type here. Okay. Or else non type here. Okay. I will show you. So here, see, so the same thing, whatever I explained, right? Here I'm trying to implement in a program. Okay. So you see, right? This is the program, our class, program class. Okay. And this is our method, which is the main method. So right, just to recall your memory, main method is the place where the compiler starts executing. Okay. So whenever you execute any bigger program, or if it contains n number of methods, it looks where is the main method, and it starts executing from there. Okay. So main method, it comes here. I am declaring two integer variables and initializing the values of 10 and 20. Okay. And if you see here, after this method, okay, I have written my function. Okay. So it is similar to the function main we have, right? So after the main method, I declared one more method, which is sum. Basically, my method name is sum. Okay. It is taking two parameters of integer type, X and Y. It is returning a value of integer type. Okay. And I have mentioned the access modifier as a static. Okay. And I can also keep public, but it is optional. Okay. So here just see, I let me, to make you easy, I will say A and B, A and B. Okay, let's try to execute this. Okay, so sum of the value is 30. So how it works is, when the compiler looks for the main method, it comes here. Okay, and okay, we are declaring two values, A is 10, B is 20. Then I am invoking this method. What is the method name? Sum of A and B. Okay, because my method name is sum, it needs two parameters, A and X and Y, some two variables. So I said sum and two variables, A and B. Okay, so this is the way you need to execute the method. You have to say like, no, the function name or method name and the parameters list. But here, you know that this method is returning one integer value. That means when you execute this method, you get a return value of sum to the main method. So this sum value I am storing in another variable called result. Okay, and once the result value is coming here, I'm printing it here. Okay, so let me explain in a more elaborated way. Uh, so here, guys, in the main method, you are invoking the, what is the method name? Sum of A comma B. Okay, so this is the way to invoke the function. Okay, here, since the method is expecting two values, I'm passing two values, A comma B. But again, since this method is returning one integer value, and I need to store that integer value somewhere in the main method. That is the reason I said, okay, result equal to. So whatever the value which I'm getting from the sum function, I'm storing in result. Okay, and here we have that sum. Okay, I am not going to write the entire program, but okay, so in the class, okay, okay, so our main program is within the class. Okay, so as of now, we have been writing everything in one program, which is main. Okay, so only main method we are writing the logic and executing it. But today I've started writing a new code in another place, which is another function. Okay, so you can write one more function also, subtraction. I'm just giving you an example. Okay, so you can always write any number of functions you want. Okay, but the execution starts from the main function. Okay, and here you are invoking the function sum from the main method, right? So here what you say is, main method is a caller function. That means, who is calling my function? Who is calling? Main method is calling some function. It is called caller function. Okay, right? Main is calling, right? Okay, so here what happens is, uh, here, okay, let me show you in the PPT. So there is a few things called here, it is called function signature. So function signature is like, see, as you know, right, compiler can only understand the machine language instructions. Okay, and if you are having 10 different functions or 100 different functions, there should be an easy way for the compiler to understand which method it needs to execute. So in order to identify which method to execute, okay, for every method, the compiler creates a unique signature. Like everyone has their own way of, writing the signature, right? That way, every method can be uniquely identified by the method signature. So how the compiler comes up, what is the signature value of a function? It considers the method name and it considers the parameters which it takes. So by considering these two parts, the method name and the parameters, it uniquely assigns a unique signature. So whenever you invoke a add function, right? So add has a specific signature. So the compiler tags, okay, hey, if the program is invoking add function, so this add function contains a signature of XYZ, then okay, invoke that XYZ location. It is called function signature. Remember guys, I said only the method name and the method parameters. It doesn't bother about the kind of return value you are going to send. Okay, so it's entry question, guys, like what is the function signature, and the function signature also contains the return value or not. Return value is not considered. It only takes the input parameters plus the function name. Okay, so this is what I'm trying to explain in the notepad, right? So here the main method, and main method, I am declared two variables x and y. Okay, and I am invoking the function by saying add x comma y, right? So when the control comes here, right? So add is a method and two values you are passing, right? So when the add method invokes, the control jumps from the main method to the function, the function definition. It comes here, okay? And here I am passing x and y, but whereas in the function I'm using a different variables a and b. So the x value is copied to a, y value is copied to b. Okay, and then I say I'm declaring one more variable sum, okay, and a plus b, which is 25. And since this method supposed to be returning a value, that value I'm returning using sum variable. So this 25 value comes back to the method, the caller function, okay, and that value is stored in the sum, and the value is printing here. Just understand how the control flow is here. It executes from the main method. Whenever you see the invocation to the function, the values will be passed to the function, and the control is moved from the caller function to called function. Okay, and then it does the whatever the processing is required, and it returns the value. And once this function invocation is over, the control comes back to the method here same, and whatever the value you are sending back is stored in the sum, and you are printing here. Just take a closer look and let me know if there are any questions. Okay, is it fairly simple, or any questions on this? Clear, guys? Okay, so now you understood the control flow and how to invoke the method. Okay, and so here you see here, right? There are two things you need to remember. One is actual parameters, one is formal parameters. Okay, I will explain in the same here only, that way you will be understanding. Okay, so here the parameters are x and y when we invoke in the main program. Okay, So these two are called actual parameters. Okay. And these two parameters are moved to another set of parameters in the method. This is called formal parameters, actual versus formal. Okay. Okay. Now the interesting stuff here. Okay. So this is a typical representation of like how the memory allocation happens when you execute the program, right? So you have two methods. One is the main method, one is add method, right? So when the compiler starts, right? Okay, so which method it executes where it starts? Is it from the main or is it from the add? Can someone explain? I just type. When the compiler starts executing, which method it looks for to execute? Just type here, like what is the okay. So thank you, Vamshi. So the main is the method for the compiler to start the execution. Okay. So first, the main method started executing. Okay. In the main method, we have two variables, X and Y. Okay. So once the main method is initiated, it creates a separate activation area within the stack memory. Okay. And okay, the main method has three variables, X, Y, and sum. Okay. And we declared X value as 10, Y value as 15. Okay. And then within the main method, you are invoking the add method. Okay. So when you invoke the add method, the control comes to the add method, and internally one more activation area gets created for add. So here what happens is a value, here the X value is moved to a value and Y value is moved to B value. Because like no, I mentioned in the main as X and Y, and in the function I mentioned as A and B. So a separate memory is created for my function, and the values are moved to here or copied to here. Not say moved is not right word, copied. The X value copied to A, Y value copied to B. And then I'm adding sum equal to A plus B in the function. That's why the sum value is 25. And from the sum function or add function, I am returning this value back to the main method. That means the 25 value which is being passed from the function to the main, the value is passed here. Okay, then we are printing the value 25. So this is how internally the memory allocation works whenever we use the methods. So clear or any questions? Guys, if you remember, like I mentioned one thing, when the main method executed, okay, memory we have only the activation area only for the main memory. It did not declare any variables associated with add function. Only after invoking the add function, the variables got created in the memory. So as I said when I started the session, I mentioned, right, in monolithic programming, everything, if you write, since you are writing everything in one single program, all the variables within the program are going to be loaded into memory at a time. But here, the A and B, these two values and sum also, these three values or the three variables did not load when you start executing the main method. They loaded only after you invoked the add function. And once you come back to the main function, these values will be erased from the program main memory. So it's only during the execution of the particular method, the associated variables are going to stay in the main memory. And once the invocation is done, it gets wiped out from the main memory. So any questions here? Okay. So remember, this is very important, guys. The different types of functions, built-in functions and user-defined functions. what is function signature, okay, and how the memory allocation happens when you start executing the program. And you also remember about the actual parameters from the main program and the formal parameters from the function. Okay, and this is how it works. So now there are 4 different types of user defined functions. It is basically depends upon the kind of variables you wanted to pass or the kind of return value you are expecting. Okay, so now we have gone through the last one, functions with argument and with return value. That means for a function, you are passing some variables as an input and you are expecting some input or some output from the function. So it has both incoming and outgoing values. Okay, so typically, like, there are some functions which does not accept any input and also does not return any value. Okay, and functions, it accepts some input but did not give any return value. But some functions will not accept any values but returns the value. So 4 different conditions: either input, either you give or not; output, either you get or not. So 4 different permutations and combinations. Okay, so here in this one, right, in the sum method, you are passing 2 variables as an input. Okay, and also you are getting a value back. So this way it is called function with arguments and return. You are passing something, you are getting back something. Okay, let me show you. So here the same program, I just little bit tweaked here. I said, so if you see here, this is the main method and this is the sum method. Okay, so I have moved all the logic. Okay, assigning the variables and printing the value, everything I have moved to the sum method. Here only I'm accepting the values and calculating and printing as well. That's why you see when I invoke the sum function, I am not passing any values. So here it is null. See, nothing I am passing here. It's all blank, no input parameters. And also, did I say like this integer a equal to? I did not mention here because this function is not returning any value, right? It is not returning any value. That's why I did not, whatever the value I am expecting, I'm not moving to any variable because there is nothing I am returning. Do you see any return value here? Do you see any return statement here? No, right? Because ideally, if you want to pass something, you have to use return. But since I don't have anything to return, okay, I did not mention. Okay, and you see, right, guys, here void. So in case if you are not returning any value back to the main method, you have to say void. Void means, hey guys, I'm not going to give you back anything. Okay, so void is a keyword used to mention the compiler that, okay guys, I am not going to give anything back to you. It's up to you. So I'm already giving a statement that it's a void. So no return values. So here no input parameters. That's why the parameters are blank here. Okay, and also I am not going to send back any value. That's why I said void. Okay, so that's why, like, here also I am not passing any variables to while invocation and not accepting any value back. So everything is moved to method. Okay, so let's see. I mean, it's same way, like, the function 30 value it prints, but basically what I'm trying to say is that, like, this method This method does not take any input and also does not give back any value. Okay, so thing you need to remember is that if your function is not returning any value back to the caller, you have to say void, because sum is a method. There is no parameters here. Okay, and there is no return type here. Okay, and access modifier is static here. So are you clear with this method without taking any parameters, without returning any parameters? Okay, I will move on to. Okay, so then I will move on to the next one. So now we already discussed about functions with no arguments and no returns, and functions with arguments and returns. Then I will just use two more examples. Functions with no arguments but returns. Okay, so here you see, guys, this is our main method. Okay, and I have one more method called sum. So here, if you see the method here, is it accepting any parameters here? No, I'm not passing any parameters. Okay, but if you see, I mentioned as an int as a return type. That means I am expecting, or the some function is going to send back a integer type of value back to the caller. Remember in the previous example, we have mentioned as void void. That means nothing I'm going to return back. But here, though I am not sending any values to some function, but some function is kind enough to send back one integer value. And since I have mentioned that we need to send back the integer value, I said return here. Okay, and since you are returning a value, okay, and when you invoke the function here, right? So here you're invoking the sum function. Since there are no parameters to pass, you said blank here, but you know that some method returns one integer value. That value you are storing in the result variable. So function, no input parameters, but one return value. So here what I did, in the previous method, I have accepted the two values, I have calculated, and I have printed the value within the function. But here, since my example is to send back one value, okay, I did not print in the method. I just say return, and once the control comes back to the main method, here I said, print that value. Okay, so clear, guys? It's a method without any input parameters, but one return value. Okay, so I will cover one more. Okay, so which one we did not cover? Function with the arguments and no return. This one we covered. Okay, so this is the one actually. So here, this is the main method and this is the sum method. So in this case, you are passing two variables x and y. Okay, x and y. So there is some input, but I mentioned void. That means you are not sending back any value from the sum. There is no return value. Okay, and since I need to invoke the function with the two variables, so I said sum equal to x, sum of x comma y. So while invoking the method, I mentioned two variables here. But since there is no return value, I am not declaring anything like this integer, result. I did not say like this because this method is not good enough to return any value because I'm declared as a void. That means no return anything. And since the function is not expected to return any value, I am printing the value within the method itself. Okay, so passing the two variables. Okay, take these two variables, submit and print within the method only. Okay, so now we have, it's a question time, guys. So we have 4 different user defined functions: functions with no arguments and no returns, functions with argument and returns, function with argument and no return, function with no argument and return. So which one do you think is the best one to use? I know it all depends upon the case by case, but what would be the ideal way of implementing the functions? Which one you feel is the right one? Just I mean, wild guess. Anyone? Vamshi, you want it? Okay, maybe fourth. Okay, any others? Anybody has a different opinion? Okay, yeah, it's very good. Vamshi, you are right. So typically we have to use the functions with arguments and return type. See, because I mentioned, in the beginning of the functions. Okay, if I show you that statement. See, a function is a group of instructions. It can be a small task or big task, but the function will perform that task completely. When I say completely, the function should be good enough to perform everything end to end within the function itself. Okay, so that can be achieved by passing the values. Where are we? Okay, that can be achieved by passing the values and also sending the return value. See, by using this, right? Okay, so you have the flexibility to have a communication between your main method and the function. So if you use this one, right, function with no arguments and no return type, is there any real communication happening between the main method and function? Because you are not sending anything and you are not taking back anything. So the functions is one of the best ways to have a communication with the main method. So it's always better to use the arguments or the input parameters and also expect the return values. Of course, it all depends upon your requirement, but this is the effective way of using this. Pass some values and get some values back. Okay. And coming back to one more important thing. Okay, I think I will just stop here with this after executing or after explaining about this. So there are two things, guys. So whenever we invoke a method or a function, okay, as you see, we are passing some variables from the main program to the child function, right? So the variables can be passed in two different ways. One is called call by value. One is called call by reference. Okay, so call by value means whenever you pass any variables in the method. Okay, so once the execution starts from the function, it creates a copy of their own variables. Like here in the main method, from the main method, I am passing two variables x and y. Okay, and invoking the add method. So what happened here? uh, from the main method, we have the memory got created to hold the values of x and y. And when the add method invoked, and once the add method is started executed, so the x value is moved to a, y value is moved to b. So it is the value is being passed to a new set of variables. This is called call by value. You are passing the actual value from a variable x to a and y to b. This is called call by value. Okay, it's very important, guys. It's an important question, interview question. Call by value. So the value from the main method is passed to the function, and it creates their own copy of the variables in the memory. Okay, so basically, you're just copy the x value to a, copy the y value to b. This is called call by value. Okay, so just see, in the call by value, the copy of the original variable is passed to the called function. Okay, so caller is the main, called function is the actual function which we are executing, whether sum or add. Because here I mentioned here, right? So this is the caller function and this is the called function. Because in order to differentiate, while explaining, right, you have to be clear whether you are referring to the function where the invocation happened or the function where the actual execution is happening. So you are invoking from the main, it's called caller. Okay, or you can say called by. So the function sum is being called by main method. Okay, and this is actually called function, right? So in call by value, the copy of the original value is passed to the called function. In call by value, the value of the original parameter is copied into the parameter of the function. I showed you, right? X value is getting copied to A, Y value is getting copied to B. So as a result, if we do not have any modifications to formal parameters, they don't have any impact on the actual parameters. That means once you invoke the function right here, so once you invoke the function, okay, suppose if you modify the a value to 20 in the add function, is it going to override the value in the main method also? Okay, in the main function the value is 10, 10 is moved to the add method, but in the add method I am going to change the value of a to 20. Is that going to be modified again in the x value? No, because this is a separate variable, this is a separate variable. Variables are different. That's why if you modify the value in the a or b, there will not be any impact to the variables defined in the main method. Okay, that's what we are trying to say here. So in call by value, the value of the original parameter is copied to the parameter of the function. As a result, if we do any modifications to the formal parameters, to the formal means in the actual function, sum or add, they don't have any impact on the actual parameters. So it will not allow you to change the actual variables using function calls, right? If you change the value within the function, it won't change in the actual main method. Okay, and one more important, the memory location referred by the formal parameters and actual parameters are different, right? The memory, you see the memory allocation is different for the main method and also for the add method. So it's separate allocation for x, separate allocation for a, also for y and b. It's basically you are copying the values of x and y and creating a fresh memory. Okay, and you are assigning a and b over there. And if you change anything in the add function for any values, there will not be any impact to the actual parameters in the main method. Okay, so that is called by value. And call by reference. Okay, so call by reference. Okay, so I think I mentioned about in the initial programs. Uh, okay, so let's imagine this is the memory. Okay, and These are all like, like memory cells, okay, like, allocations. Okay. So let's say, there is a text here. Okay. What's happening? Hmm? Okay. So let's take this as a primary memory of RAM, and RAM has, these are all the, like, the memory locations. And whenever you store any value, like suppose, like, you store the X value as a 2 here, okay, and B value as 5 here, let's say 4, okay. So whenever there is a value stored in the memory, each cell within the memory has a unique address. Okay, so this cell I am referring as 00x, and this location I am referring as 00y, and this location I am referring as 00z. I am just giving you some illustration purposes. That means what I'm trying to say is that, like, every location in the memory has its unique address, and that is the way, okay, when the program execution starts, it knows that, okay, if it wants to pick the value of a, which is 2, okay, it it goes to this particular cell by referring to this address 00x, and if it wants to pick the value of 4, it goes and see, it, because there are thousands of cells, right? We have 16 GB memory, we have 8 GB memory. So how the compiler knows where to go and pick the value? So it will not, remember the cell A or cell B. It remembers by the cell address, memory address. So it refers this one 00x or 00y or 00z. Okay. So what I'm trying to say is that every memory cell in RAM has its unique address, and compiler picks up the value based on that address or the location. Okay. So in call by reference, what happens is, okay, so here in the call by value, the X value is being copied to A and Y value is copying to B, right? So, but in the call by reference, what happens is, here we do not pass the value of 10 or 15 to the add method. Instead, we pass the address of the X value and address of the Y value. So what happens is, okay, let's say integer A X equal to 10, integer Y equal to 20. Okay. Let's say in the memory, this is the memory is where the 10 value stored is 00x, the address, memory address basically. Okay. And for this memory address is 00y. Okay. And here when you invoke, okay, the method here, okay, here A and B, right? In normally in the call by value, here it takes the value of 10 and 20 and passes those values 10 and 20 to the method here. Okay. So here we are passing the values, but in the call by reference, what happens is, you will not pass the actual value. Rather, you pass the memory address of X and memory address of Y. Okay. So you are passing the memory address of X and memory address of Y. That is called call by reference. That means instead of passing the actual value, you are passing the memory location of the actual parameters. This 2 and 4, right? So 2 and 4 are the ones, or 10 and 20 are the ones which are stored in the memory. So instead of passing these actual values, you are passing the location of this variable. Okay, so that means what happens? Since you are passing the memory address of the variable, when it execution starts here, right? For the called function, there is no need of creating its own memory cells. So when the program execution starts, right, it only refers the address. That means the address is what basically for the actual parameters, right? So it directly refers these variables. It doesn't need to create its own instance. So guys, clear and clear the call by reference. It's very important, guys. Okay,
Yeah.
very important. Okay, I need the
Yeah.
answer from everyone. Okay,
Yes.
so okay, from others, please. You're clear. So if you see in the call by reference, okay, you are passing the address, actual memory address of the variable. So since you are passing the actual address, the parameters, both the actual parameters and formal parameters, both refers to the same memory location. That means you don't need to create any separate memory allocations when the method started executing. Okay, so basically you are saving the memory space. Okay. Okay, so this is what I am trying to illustrate here. So basically, if you are passing the value as a call by, okay, so the original value will not be modified, because when you use call by value, there is a separate instance created for the parameters being passed. So call by value, there is no impact to the original value, but if it is call by reference, there is an impact, because in the call by reference, the formal parameters contains the address of the original variable. So whenever you make any kind of modifications for the formal parameters, that is indirectly hits the original value or original variable. I'm not sure whether I have taken any example. Let me see if there is any I can explain. Okay, yeah, I have one call by reference. Okay, so here this is my main method. This is my update value. The function name is update value here. Okay, here in the update value, I mentioned as void. That means I am not returning any value back to the main method. Okay, you see here, normally in the parameters, we used to say integer or float or double, but I said as refer. So refer means I am asking the compiler, instead of picking the a value 15, pick the memory location of the a value. That means instead of taking the value 2, take the address of the value 2, that is 00x. So when the, okay, so let's say here, so a address is 00x. Okay, so I am passing one variable a. Okay, and since it is a void, I did not mention any return parameters here like int I or something, no return value. Okay, so the program started from the main method a equal to 5. Now I'm invoking the update value function by passing a reference variable. Okay, so instead of, when I use a reference word, right, when I use a reference word, right, instead of passing the actual value, I am passing the address of the a variable, which is 00x. So it comes here. Okay, it comes here. So here the b value. So b contains, because I said the separate variable, right, b. So what b refers? B refers to the same address as a. So that means whatever the modifications you do in the B value, okay, the B value is nothing but 00x. 00x means it is the memory address of the value A. That means both A and B are referring to the same memory location. This is A, this is B, okay, and this is the value. What is the value I stored? 15, right? So I stored value 15 here, okay, and so A is referring to 15, okay, and the address here is 00x, okay. So A value is stored in the 00x address, the value is 15, and when I use the reference keyword A, so here instead of passing the value 15, so the B value contains the address of 00x. So when I say 00x, basically both are referring to the same memory location. Okay. So A also refers to 00x, B also refers to 00x, which contains the value 15. So here I modified the B value as 30 within the program here. Okay, then that means here instead of 15, it will contain 30. Okay. So 15 is modified to 30. So initially it contains the value of 15. Okay. But later what I did, I have modified to 15. So 30 is gone now. Okay. We only have 50 here, 30 here, right? Because A and B both are referring to the same memory location, and initially A became 15, and then I have updated the reference value by using a B pointer, which is equal to 30. So both are referring to the same memory address, and ideally it should print the value of 30 here. So let's see whether it is printing. What's happening? Okay, this one, right? Okay, so it printed 30. So what I'm trying to say is that, like, in the call by reference, there is no duplicate set of variables gets created when you invoke it, since you are pointing to the memory location in rather the variable. So advantage is that you can save your memory space. As I said, like, if you have too many variables in the program, it takes time for the compiler to load everything into the memory and execute. So you can effectively utilize this call by reference mechanism, which saves a lot of space in the memory. And also it is very fast, guys, very fast. Why? Because you are directly referring the memory address rather than the variable name. So directly it points out to the memory location rather than going to what is A and again going to A and see what is the A location address and again going to location. No, there is no two steps here. Directly it knows the B contains the memory address. Directly it goes to that cell. Okay, so clear, guys? Call by value and call by reference. I think we have enough. We have shared lot many things. Okay, spend some time over the weekend and try to
Yes.
understand. Okay, yeah. So try to understand the different ways of executing the methods. Okay,
Yeah.
call by value, call by reference, method signature. Okay, so very important, guys. Because see,
Oh,
as you
yeah.
know, as you know, class contains variables and methods. It's always methods. Okay, so you need to, because if you know how to write a function, okay, so 50% of your work is done. because everything we deal in OOPS is methods only. Everything we write in methods. So once you are familiar with the methods, just know we will just need to enhance or extend the class and start creating the objects and you consume it. Okay, so try to go through the functions. Okay, so there are two things which you are not 100% clear, which I'm going to explain next week. One is access modifier, one is access specifier and modifier. These two are I will explain in detail when the OOPS programming is going to start in next week. But for now, just remember that access specifier is you can say public or private or protected, and modifier is whether it is a static or partial or sealed. So by default you can say you don't need to mention anything for access modifier, it is optional. And for modifier you mention as private, because that's how I declared everywhere, you see. Okay, so see here, static add declared. So just remember that you try to declare static, just blindly just refer like that. Okay, when I'm going to explain the different ways of modifiers, then you will understand where to use and what to use. Okay.
Yes. Yeah.
So please go through. Okay, and happy weekend, and we'll
Yeah.
again
No,
meet on Monday.
yeah. No, thanks for the class. Happy
Okay.
weekend.
Yeah, thanks guys, happy weekend. We'll again meet on Monday. Thanks. So recording has been stopped, right, Krishna?